Hello everyone, welcome to Chapter 1.1, which is identifying points, lines, and planes. We are going to look first at the vocabulary. We're going to look at undefined terms. The first term is what's known as a point. A point has no dimensions, so no length, width, or depth. You represent it with a dot, and you use a capital letter to represent it. So this would be called point A, or you can just call it A, and by the one letter you know it's a point that we're referring to. Second undefined term is a line. It has one dimension. It's represented by a line with two arrowheads, but those extend without end. Described with two capital letters with a line above it or an italicized lower letter. So this is what a line will look like. If I draw a line, it's going to look something like that. We're going to have 2 points on the line. So we can call one A, and we can call the other one B. So we could call this line AB. Or we could draw A and B with a line above it. Or if we have, for example, a lowercase letter italicized, like an L, we could call it line L. Okay? More vocabulary. The third undefined term. Remember, undefined terms are terms that have no formal definition. They're just easy terms that everybody understands. A plane is the third undefined term. Now, a plane is going to look like a shape that looks like a floor or a wall, but it extends in all directions without end. It has two dimensions, which means it has a length which is infinite and a width which is infinite, but it has no thickness to it, no height. So this is how you would draw a plane. It would look something like that. You can kind of see how this would look like a ceiling right here. In order to describe a plane, we use 3 capital letters. So we have to have 3 points to make a plane. 2 points make a line, and 3 points make a plane. So we've got that. Or the other thing we can do is we can take a letter such as M, put it in the corner here, and this is not connected to a point, so we could call this plane M. Okay? Now how do we describe or write this out? We can say plane ABC. Sometimes you'll see something like this. They'll actually draw what looks like a plane, and you'll see ABC. Or you can do plane M. So those are the 3 ways to describe a plane. Next, we're going to talk about collinear points and non-collinear points. Collinear points are points on the same line. Non-collinear points are points that are not on the same line. So this is pretty easy to understand, I think. If I was to draw collinear points, we can draw 2 points, and those 2 points will always make a line. So if I draw a line, that hopefully goes through both. That was a horrible line. Let's try that again. If I draw a line, it will go through the 2 points. Those are collinear. If I then take a third point, these 3 points together would be non-collinear. I can have as many points as I want, so we could have 3 points that are collinear, or we can have 3 points that are non-collinear. 2 points will always make a line, so 2 points will always be collinear. Coplanar points and non-coplanar points. I'm going to draw a plane. And like I said before, 3 points always make a plane. So if I put these 3 points here, those would be coplanar points, and 3 points will always make a plane. If I draw a 4th point down here, these are non-coplanar points because they can't all lie on the same flat surface. But I could have a 4th point here. These are still all coplanar. And in fact, this point, and that point are still coplanar because we can draw a plane that connects all 3 of those. There's a flat surface that can cover those. 3 points, always coplanar. 4 points, sometimes coplanar. Defined terms. We looked at undefined terms. Defined terms are terms that can be described using known words. So using the undefined terms, basically. A line segment is a part of a line that consists of 2 points and all points on the line that are between the endpoints, where the endpoints are the points that define a segment or ray, and we'll talk about rays in just a sec. So if I was to draw a line segment, it would look something like this. You notice there's no arrowheads, so if I have something like this, I would represent it with a line with 2 endpoints. This is just part of the line, so we can call this, let's not call it line, let's call it segment. AB, or we can write AB and put a little segment above it. We could also call this, by the way, segment BA. Either one would be fine. Okay? We talked about endpoints, so we can move on. Array is a part of a line that consists of a point called an endpoint and all points on the line that extend in one direction. If we want to draw this shape, what we're going to do is we're going to have an endpoint and then an arrowhead at the other end. So there's our representation. If I call this A and I call this B, we can call this ray AB, or what we can do is we can say ray AB, where we have this on top. Now you notice I did it in this direction on purpose because we can't say BA, because that would mean it would start at B and go through A. It would go here and go in that direction. So this is no good. Okay? Opposite rays. Opposite rays. If I draw a line, let me see. If I draw a line, and let's say I put 3 points on there so that we have C in the middle. Ooh, try again. So that we have C here, A here, and B here. So again, C lies between A and B. We can say that CA, where CA starts at C and goes this way, CB starts at C and goes this way, they form opposite rays. So basically, we have 2 rays that form a line here. Okay? Intersection we're going to talk about a little bit later in this in the examples, but the perfect example of an intersection would be if I drew a line like this, and I drew a line like this, then the intersection would be right here. Okay? So the intersection of 2 lines, we can have 1 point or we can have no points. Here's some examples we're going to look at. It says give 2 other names for line PQ and for plane R. So let's see, line PQ, we can say QP because we can write it in the other direction. Or we have a small letter N there, so we can say N. Okay? Now for plane R, if you notice there's a lot of points on there, so we just need to use 3 of those. So I'm going to name it this way and choose 3 points like V, S, P. Or what we could do is we could say plane VPT would be fine. Okay? Here's another example. Give 2 other names for ST. That shouldn't be too hard because there's 3 points on that line. There's also this letter right here. Here's ST. So I'm going to call it PT with the 2 arrowheads on top. Or we could call it M. Okay? Name a point that is not coplanar with Q, S, and T. Well, if you look, Q, S, and T don't look like they're on a plane, but remember 3 points make a plane. So anything that's in this area would be considered on the same plane. So Q, S, T are on the same plane. So is P, so the only thing that's not on that plane is V. Another name for segment H, or GH rather. Now we have to be careful here. What we're talking about is the segment that goes from here to here. So since the 2 endpoints are what define it, we would call this segment HG. Okay? Name all rays with endpoint J. I'm going to name these very specifically. So the first thing I'm going to do is it has to start with J, and we have J and E. So we would say start with J, go through E. We would say JF. We would say JH. And the last one would be JG. Okay? Which ones of these are opposite rays? Again, I grouped it that way on purpose. These are opposite rays. And the reason for that is because these 2 rays form a line. These 2 also are opposite rays because they also form a line. If you can't see that, ask about it tomorrow. Here's another one. Give another name for EF. Well, the endpoints are at E and F, so there's really only one choice. I'm going to call it segment FE. We want to know if, for this one, if HJ and JH are the same ray. I don't even need to look at the picture for this one, because if I look, the endpoint for this is H and the endpoint for this is J, so they're not the same ray. So for the first part, we would say no, they have different endpoints. Okay, and then HG or HJ and HG. If we look at the first one, we've got H going through J and going in this direction, and we've got HG. If you look, it's the same exact ray. It's going to go in the same direction. So we would say yes. Same endpoints. And direction. The reason why we say direction, by the way, is if I had said, for example, JE and JF, those are not the same ray. Those are opposite rays. So we have to be careful there. We have to explain ourselves completely. Alright, sketch a plane and a line that is in the plane. I'm going to do a plane. And we want this to be laying down here, so I'm going to draw it like this. So there's our plane, and then we have our line laying in the plane. The intersection of this plane and this line would be the line. Okay? A plane and a line that does not intersect the plane. So there's our plane, and then we have it sort of like, think of that like the floor, and this line is above the floor. So the intersection here is none. The third one, we've got a plane, and we want it to intersect at a point, so I'm going to draw a ray that goes up here, and I'm going to draw a little dashed line here, and have it come out here, where the intersection is here. So they intersect at a point. We can have the line be the intersection, we can have no intersection, we can have a point be the intersection. Okay? Sketch two planes that intersect in a line. Here's our finished product here, and think of this as like a corner. Like if we were to look, this was a wall and this was a floor, this line right here would be the intersection. So I'm going to start off drawing just like a rectangle. So I'm going to draw a rectangle. Okay? And then I'm going to draw, as best I can, I'm going to draw this flat surface right here. So I'm going to go out and over, and then over here, and go back. And then I'm going to have to do some dashed lines here. So I'm going to go out this way, continue it until I reach this point, and then I go across, and then solid again. Okay? Now the intersection here would be a line, so we would want to draw a line where those meet. So mine's maybe not as neat as theirs is, and I don't expect you guys to be perfect artists, but it should look something like that. Okay? Last one. Sketch two different lines that intersect in the plane at the same point. Well, let's see what we can do. There's a couple ways we can do this. There's no perfect answer for this, but I'm going to draw a plane. And then, for example, I could say, let's put a line in here. And then let's put another line here. Okay? So that's two different lines that, intersect. I am absolutely wrong here. So I'm going to back that up. Sorry. So I'm going to have to actually draw it like this. Watch what I do. I'm going to draw a line going up here, because they both have to intersect at just a point. So I'm going to draw a dashed line and make it solid, and then I'm going to draw another line here, and a dashed line, and there you go. These two lines intersect the plane at a point. Where the way I did it before, those were actually two lines that are intersecting on the plane itself, so that doesn't really work. That's a better answer. It says name the intersection of PQ and line K. Alright, so here's line K, here's PQ. Looks like there's a point intersecting there, so the answer is M. Plane A and plane B, well, remember two planes intersect in a line, and that line is line K, so we can just put lowercase k. And the intersection of line K and plane A. So let's take a look at that. We've got line K, which is here, and we've got plane A. Well, the line is laying in the plane, so we can say line K is our answer. Alright, we're all done here. Make sure you check over your notes. If you need to rewind this, do that. Make sure you write down everything. Look at the classwork that we have going on tomorrow, because I expect you guys to be ready to ask any questions you have. The best thing for you to do is look it over, maybe do a couple problems, make sure you know how to do it. If there's any questions you have, make sure you ask in class tomorrow. Alright, thanks a lot.